section P-6, which is rational expressions, and that's the part that's going to be new. All right, and then we will go over at the end, we'll do some simplifying a complex rational expression. Okay. All right. Again, since this is the review chapter, rational expressions you would have done in an Algebra 2 class, it would have taken an entire chapter. So every concept, you would have learned how to simplify them and then multiply them and then divide them and add them and subtract them. And each one of those would have been one day. All right, what we're going to do is we're just going to briefly go over all of that, all right, in one shot here. Okay, so to begin with, they're going to expect you to be able to simplify some rational expressions. All right, and this is going to be dependent upon you being able to factor. All right, that's why the previous chapter was factoring. All right, so if I had something like a 3x minus a 9 over, say, an x squared minus a 6x plus a 9. All right, you could, any type of factoring that you've encountered, you're going to have to possibly do. They really do like a lot of trinomials. They like a lot of take out greatest common factor. Okay, so on that top, I've only got 2 terms. Looks like we can take out a 3 and factor that down to, when I take out greatest common factor of 3, I'm going to have an x minus a 3 in the top. All right, this trinomial has that leading coefficient of 1. Okay, so we're going to do just a regular old guess and check. We know that the first one's going to be x. Factors of 9. It's going to work. I got to get a 6, so I can't use 9 and 1, so I'm going to have to use a 3 and a 3. And I need a negative 6 here, but a positive 9. So negative, negative. Negative 3 times negative 3 will give me the positive 9. Negative 3x. Negative 3x gives me the negative 6. All right, which is what we want to happen. And then something's going to cross out in the top. You cross out binomials together. Okay, so binomial of x minus 3, binomial of x minus 3. You're left with just the 3 over the x minus 3. And then there's no reason to put that bottom one in a set of parentheses. We just usually write it like that since there's only one binomial term there in the bottom. Okay, so you would have done lots of those in Algebra 2, probably an entire section of that. All right, then right after you simplify, the next easiest thing to do with rational expressions would be to multiply and divide. Okay, because you do not have to you don't have to work with common denominators or anything when you do that. So let's take a look at some. Again, they're probably going to say simplify. It might say multiply. Okay, you should always put it in lowest terms whenever you do that. So let's take a look at x squared minus 9 over an x squared times an x squared minus a 3x all over an x squared plus an x minus 12. So this would be an example of multiply. If it was dividing, think of this as fractions, right? This is a fraction times a fraction. So if that was a divide, what's the rule for when you divide fractions? Yeah, keep it, switch it, flip it. All right, so any of that arithmetic stuff, you know, previously you got to apply too. But this is straight multiplication. All right, now there's lots of different ways you can do this. You can factor each one of those spots and rewrite it completely. All right, or sometimes people will take this and factor it and then write it right above it. Okay, I really don't care which way you do. All right, now x squared minus 9 is the difference of 2 squares, right? So that means I can have an x minus a 3 and an x plus a 3 right there. Very dependent upon can you factor these effectively. All right, now if you've got a single monomial term here, it's x squared, you can't factor that, okay? Over here, I've got 2 terms again, but not difference of 2 squares, so I can only take out a greatest common factor of an x. Okay, so if I take out that x, I would be left with an x minus a 3. All right, so that's no longer there. The only problem with, I tried to do no more than just a line through that, because if you literally scribble it out, you can't go back and look and find your mistakes. Okay, down here, you're going to have a trinomial. So it's trinomial with a leading coefficient of 1. So you're guessing and checking this. So an x and an x. All right, and then let's see. I got to get a 1 there, so I can't use 12 and 1. I can't use 2 and 6. I can use a 4 and a 3. 4 times 3 is going to give me the 12. To get a positive 1 here, but a negative on the 12, that 4 needs to be positive, and the 3 needs to be negative. That's going to give me a negative 12. When I check there, 4x, negative 3x gives me that positive 1x. All right, now, that's what I would do first. I would go and factor each one of the locations that you can, and then cross out things that are the same. Now, when you cross out, something's got to be in the top with something in the bottom. Now, I got an x minus 3 here, x minus 3 here. I've got an x minus 3 here, okay? 1 for 1, top and bottom. So if I wanted, I could cross this one and this one out. One's in the top, one's in the bottom, they match. If I chose not to, I could do this one and this one. One's in the top, one's in the bottom. All right, and my guess is you have a tendency to want to do it on the angle for whatever reason. I don't know. Just when you first learned how to do fractions, everything was crossing out on that angle, but it does not make any difference. One on the top with one on the bottom. Okay, so since you probably will like the angle one, we'll cross those two out. Okay, now you got to look really carefully because at this point the problem is starting to get pretty cluttered. All right, so every now and then it wouldn't hurt you. You could rewrite and then see if there's more to cross out, if you can still read your writing. All right, because I'm seeing an x right there in the top. I'm seeing an x squared right here, so I can cross out one of the x's, right? X on top is going to go away, and then one of them in the bottom. So basically, I can just get rid of that too, because that would leave me with one in the bottom. At any point in time, when it gets too cluttered, rewrite it, okay? Everything that's left in the top, I've got that x plus 3. I've got an x minus 3. All right, in the bottom, looks like I've got an x and then an x plus 4. Now, technically, that's the right answer. It is in factored form at that point. All right, I honestly don't know what Math XL is going to ask you to do. They may expect you to go ahead and multifoil that top out and distribute the x. When you are working these out by hand for me on a written test, I want you to stop right there. You stop before you make a mistake. You have factored it. There's no reason to go ahead and multiply it back out. Okay? Is it an equivalent answer? If you do, yes, as long as you don't screw up your multiplication. But I still don't want you, I want you to stop. All right, so far so good? It's coming back, right? You should have done tons of these in Algebra 2. All right, let's go ahead and let's do a keep it, switch it, flip it. So let's do a 4x squared plus a 10 all over an x minus 3. And then let's say they put a divide in there and they give you an 6x squared plus a 15. And then they do all over an x squared minus 9. Now, as an extra step, all right, this one, I mean, I know a lot of you are going to want to skip this step. I really wouldn't. All right, we know this is a keep it, switch it, flip it. All right, you keep the first fraction, you switch this to multiply, you flip the second fraction, okay? I would actually rewrite the entire problem before you start to factor. All right, 4x squared plus 10 all over that x minus 3. All right, switch this to a times sign. Flip this around. X squared minus 9. 6x squared plus 15. Skipping steps, some of you are going to start to factor right away and do all that kind of stuff. You're just more likely to make a mistake. That's why I'm recommending this. Okay. It looks like I've got two terms. I can take out a greatest common factor here. Probably going to only be a greatest common factor of 2. And then this time I'm going to show you the other way to do this. I don't have to cross it out and make the problem look messy. I could go to a new line and go, okay, here I'm going to factor out a 2. So take out that 2, I'm going to have a 2x squared plus 5. Okay, rewriting keeps it from getting messy. That x minus 3 is going to stay on the bottom. Hopefully up here on the top, you're going to recognize that being the difference of two squares. So an x plus a 3 and x minus a 3. All right, and then on the bottom, again, this is no more than take out a greatest common factor of 3. So I'll have a 2x squared plus a 5. All right, so this would be the other way to do it. If you're not going to cross out and write it above, you're going to rewrite it as a new problem all the way down to the bottom. All right, so it looks like I've got a 2x squared plus 5 as a matching binomial that I can cross out. And again, that's on the angle. Wouldn't have to be. One's in the top, one's in the bottom. All right, this is a binomial. Even though there are no parentheses around that, that still is considered a binomial on the bottom. So this binomial of x minus 3 crosses out with that one. Okay, and then I got a 3 in the bottom. I've got a 2. I've got that x plus 3, nothing else left. So I'm going to have 2 parentheses x plus 3 all over 3. All right, and again, you could distribute that 3, All right, or you could stop before you make a mistake. Okay, might be a good idea to stop before you make a mistake. Okay, so multiply and divide, okay? Those are the easier two operations as opposed to adding and subtracting. All right, now this is just like adding and subtracting fractions because they're algebraic fractions. All right, when you add or subtract fractions in general, what do you have to have? You have to have common denominators. Okay, so if we do add and subtract, I'm just going to put add and subtract because we know that we're doing rational functions here. All right, we're going to have common denominators. All right, now they will give you a couple easy ones at the beginning of the assignment. They always do that just to see, you know, how you're doing here. Let's do a subtraction one, though, that puts a little bit more effort on your part. Let's do like a 4x minus a 10 over an x minus 2, and then let's subtract an x minus 4 all over an x minus 2. If this was add, it would be no more than just add up all those terms, right? But this is subtracting this entire quantity. It is subtracting, okay? So technically, I've got to take that -1 that's right here and distribute it. I got to go through and change all those signs. So we know that if we add or subtract fractions that have common denominators, then we just have one of the denominator, right? Because you keep the denominator. So what I would probably do, as opposed to trying to do this in my head, I'd write it all out. I would write out a 4x minus a 10. Now go through and change the signs over here. That's going to be a minus x and a plus 4. And then we know it's going to be all over that x minus 2. So go ahead and add them, but don't actually add the terms on the top. Rewrite them because it's subtraction. All right, now put your common like terms together. 4x minus that x is going to give me a 3x. All right, and then -10 minus 4 is going to give me a -6. And then an x minus 2. All right, and then, am I done or do I have to keep going? Gotta keep going, right? Because I got to take out that 3. All right, so that's nothing happened over here because we were already completely factoring them. But like this, anytime you're left with something that you can now factor, you got to keep going. Take out a 3, which will give me an x minus a 2. And then this, the binomial of x minus 2 crosses out, leaves me with just a whole number of 3. Okay? Simple. Very simple answer, but we can do that. All right, if this was an add problem, and all I would have been doing was adding those 4 things up, I probably would not have written this step because it already had common denominators. I could have added the x terms, I could have added the numbers, and wrote it over x minus 2. That step is needed when it's a subtraction. Okay. All right, now let's go an easy one, because I don't think they're going to do too awful bad hard ones when they're not common denominators. Let's do a real easy one to start with, just so conceptually we have it. Like, let's do like a 3 over an x plus a 4 plus a 6 over an x plus 5. These do not have common denominators. I've got to get common denominators. All right, the easiest way to come up with a least common denominator is just to take one of everything they've got. All right, so I want a denominator of x plus 4, x plus 5. Okay, that would be my least common denominator. Okay, that would be my least common denominator, an x plus a 5 and an x plus 4. All right, now, in other words, I've got to multiply this fraction by something so that its denominator looks like this. I've got to multiply this fraction by something so that the denominator looks like this. All right, I'm going to do it right on that problem. Okay, this one is going to get multiplied by, what's missing? The x plus 5. So an x plus 5 over an x plus 5. This fraction is going to be multiplied by what it's missing in the denominator, which is the x plus 4. So x plus 4 over x plus 4. I'm choosing to multiply by the same thing over itself because that's multiplying by 1. I'm not changing the problem. Okay, now the bottom, you really do need to write this just like this. Okay, a lot of people want to just write the x plus 5 up there. but technically that's not mathematically correct. Put both of them down there so that I now know, oh, this, I've got common denominators because this now matches this. And I'm just going to write that one time as my denominator, okay? So I'm going to write the x plus 5. I'm going to write the x plus 4. Okay, now up here on the top, this is a binomial. X plus 5 is a binomial. And I'm multiplying it by that 3. So what do I have to do? The 3, I have to distribute the 3 to both those spots. Okay, so that's going to give me a 3x and a plus 15. Okay, now I have to do the exact same thing over here. I know I'm going to have a plus probably. That's a positive 6, so I'm going to go ahead and put that plus sign down there. But this x minus 4 is a binomial. I'm going to take that 6. I'm going to distribute it because I'm multiplying a single number times my binomial. That'll give me a 6x plus a 24. Now I can add some like terms on top. I've got a 3x and a 6x is going to give me a 9x. That 15 and 24 is going to give me 39. And then I've got the x plus 5 on the bottom. I've got the x plus 4 on the bottom. Okay, now, can I take out a greatest common factor on the top? I can, right? I can take out a 3. The question is it going to do me any good? All right, it's not going to do me any good. I could go ahead and do 3, and then that'd be what, a 3x plus a 13. All right, I could do that, but nothing crossed out after I factored it. So unless it wants it in completely factored form, you should be able to stop right here. I mean, honestly, you're going to have to read the directions very carefully in Math Excel to find out what form they want the answer in. All right, but you always need to look at whatever you've got in the top and bottom. If it can still be factored, you need to at least check to see if something crosses out. Okay. All right, now save the best for last. All right, do we think we're good on that? Add, subtract, multiply, and divide, rational expressions, because this is a review for that. All right, now the next thing's going to be brand new stuff. Okay, you've not seen this stuff. We're going to be simplifying a complex rational expression. Now, specifically, we're going to do a shortcut. We're going to multiply through by the least common denominator. You simplified complex rational expressions in Algebra 2. However, you probably did it more on the lines of keep it, switch it, flip it. You looked at it more like a great big complicated division problem as opposed to a complex rational expression. We want to do this very, very quickly. You want to multiply through by that least common denominator because if you go on to calculus, all right, you're going to have limit problems. You're going to have derivative problems where you're going to have some really complex expressions. So you don't want to do tons and tons and tons of algebra to simplify that. You want quick methods for the algebra to simplify it so you can apply the calculus. Okay, so let's suppose we all know what hopefully we know what a complex rational expression is, right? It's going to be a fraction in the top of a fraction and then possibly a fraction in the bottom. Not always, but at least one fraction in the top or the bottom. Okay, so let's start with, here's the great big fraction bar. I've got a numerator, I've got a denominator. In my numerator, I'm going to have a 1 over an x plus a 7, and then minus a 1 over x, and then all over a 7. Okay, that's a complex rational expression. All right, we don't like this because this makes this complicated. I've got fractions in my numerator. So my goal when I simplify this is to get rid of these fractions. I want this fraction gone, I want this fraction gone. Now in the denominator, do I have a fraction? It's already a whole number, right? But technically, I mean, it could be 7 over 1, but that's fine. It's just a plain 7, okay? Now I need to come up with the least common denominator. I'm going to look at all my individual denominators. So I'm going to look at that x plus 7 right there because that's a denominator. I'm going to look at this x because that's a denominator. What's the denominator down here? 1, right? So I'm looking at x plus 7, x, and 1. Okay, my least common denominator is going to be whatever I get when I can multiply all three of those. So it's going to be an x times x plus 7. Okay, so I looked at this x plus 7, this x, and then this 1, which is not really in the problem, to come up with that least common denominator. Now, I'm going to multiply through by that least common denominator. All right, I'm going to put square brackets around this. Now, x times x plus 1 is not, in that form, is not written as a fraction, but over 1 it would be, right? And these are fractions, so I want this as a fraction. So I'm not necessarily going to write over 1 because it clutters up the problem, but I'm going to write it up high so that I remember it's in the numerator. All right, that's because it's even with those numerators. So I'm doing that up high, so I'll remember that is in my numerator. All right, so I'm going to multiply times that. I'm also going to multiply the bottom times that as well. All right, so x times the x plus 7. Multiplying through everything in the top and everything in the bottom by that least common denominator. Now, do I have a binomial in the top? I do, right? So that means I've got to take this quantity and distribute it to the first term and distribute it to the second term. Okay, now what did we just do when we multiplied fractions? If something matched, we crossed it out, right? Top and bottom. This is in the top, this is in the bottom. When I take this times this, what crosses out? Yeah, the x plus 7s go away, which makes the fraction go away. And I'm only left with 1 times x, so x. Right, I just made the fraction go away, which is what we want to happen. Okay. Now, let's distribute here. 1 over x times x plus 7. All right, this is in the top. This is in the bottom. What crosses out? The x's cross out. And I'm left with a binomial times 1. So this binomial, the set of parentheses are extremely important because of the minus sign in front. So technically, I've got a minus 1 times that binomial of x plus 7. All right, crossing out the x's, keeping that binomial with a set of parentheses is important because it was the minus 1 times that. And just showing that just so that it kind of stands out a little bit. Now over here, this is over 1, this is over 1, so I'm just going to multiply all of this. I am not going to distribute. Do not get in a hurry to distribute. Just squish it together. 7x, x plus 7. Leave it like that because chances are something's going to cross out later. Okay, don't get in a hurry to distribute that. All right, now I am going to distribute in the top. I'm going to simplify this in the top. All right, basically that's a negative and a binomial. I got to go through and change the signs, right? So I'm going to have an x and then a minus x and then a minus 7. I'm going to not distribute on the bottom. All right, do I have some like terms in the top now? X minus x, that goes away, right? So the x minus x goes away. All right, I'm left with a what? Kind of hanging out right there. I've got that negative 7 still in the top. And then I've got a 7 and an x plus 7. All right, now do you see why I didn't want to distribute that? I did not want to distribute that because now I can real clearly see I've got a 7 out here, I've got a 7 up here. All right, I will have that negative that's still left in the top, but that's okay. Negative 1 over, and I still would not distribute unless for some reason you have to for your Math Excel answers. But otherwise, I would stop right there. Now, yes, this took a whole lot of work, but it's less work than if we would have done this the same way you did in Algebra 2. If I would have said this expression divided by and written it out horizontally 7 and then keep it, switch it, flip it, and do all that other kind of stuff, would have taken a whole lot more work. All right, this really is a quick method, and I was trying to show absolutely every step so that you're thinking, when you get really good at this, you can go through this really, really fast. Okay. All right, let's take a look at another one. Actually, we may do 2 of these because it's just brand new, so you need to see lots of examples. Okay, so far so good. Still see some pencils moving. Okay. All right. The thing is, you have no idea what that original problem is going to look like. Okay, so this one might be like, say, an x over 3. And then let's throw a bunch of minus signs in there because we don't seem to like those as well. And then again, an x minus 3. I'll get a fraction on the bottom in the next example. Okay. First thing I got to do is I got to come up with my least common denominator. Okay, but this right here is a fraction. So it has a denominator of 3. Okay, is this a fraction? Not, right? So I don't have to worry about a denominator here. Is this a fraction? No, so I don't need to worry about any denominators because this is over 1, this is over 1. So the only denominator I have is that 3 right there. So the least common denominator is 3. And that technically right there is the only fraction I need to get rid of. Okay, that's the only fraction I need to get rid of. So I'm going to multiply the top. And I can be square brackets, I can be curvy brackets. It really doesn't make any difference. I am going to put the 3 in the top, though. So you kind of think of this as 3 over 1. I got to multiply the bottom there by that 3. Okay, when I do that, the top, I'm going to distribute that 3 to both of those terms. And I'm going to kind of try to do this multiplication in my head. X over 3 times 3, this 3's in the top, this 3's in the bottom. So they're going to cross out, which is what we want to happen because we want that fraction to go away. So the 3's cross out, I'm going to be left with just an x. All right, if when you multiply through that by that least common denominator, in this very next step, all your fractions in the numerator and all the fractions in the denominator should be gone. And if they're not gone, then you're doing something wrong. Okay? All right, 3 times the 1 is just going to be a 3. So that'll be a minus 3. All right, and then again, don't get in a hurry to distribute whatever's on the bottom. All right, and this is squished up on the right side. If you don't like it on the right side, you may move it to the left. It doesn't make any difference. You're more used to seeing numbers on the left. All right, but look at why I'm telling you don't distribute, because it matches with something in the top. All right, so now I can legally say, ooh, here's a binomial I can cross off with a binomial in the top. It's going to leave me with that imaginary 1 right there. Then I'm going to have a 1, ooh, a 1/3. I just got down to a 1/3. Very, very simple answer. And see, in that one, we went quicker. All right, there was a little bit less work to it. All right, but the more you do these, the better off you're going to be. Okay, let's do one more. I think I'll have room to get it right here. Let's do like a 1 plus a 1 over x all over a 3 minus a 1 over x. Before you rush into starting it, kind of take a look at what you got, right? I've got a whole number integer here, and I've got a fraction. So I'm trying to get rid of this fraction. I got an integer whole number here. I've got a fraction here. I want to get rid of this fraction. When I simplify this, when I multiply through by that least common denominator, I want this fraction gone. I want this fraction gone. Now, I've been saying come up with that least common denominator by looking at denominators, individual denominators. This one doesn't have one. This does. It's x. This one doesn't have one. This one does. It's x. What's the least common denominator? How could I, what would I multiply this by to get rid of the 1 over x? I'd have to multiply by x, and then cross it out. If I multiply by x over here, would it cross it out? So the least common denominator is x. All right. Over here, let's go back to this first one we did. On this one, we took one of everything I had, right? I had a denominator of x and I had an x plus 7. So I used x times x plus 7 for my least common denominator. But because these two things are the same thing, I don't want to use an x squared because that's not the least common denominator. It's a common denominator. It's not the least common denominator. Okay? So least, let's see, I'm going to write it over here. Least common denominator then is just going to be an x. Okay, so I'm going to multiply through on the top by an x. I'm going to multiply through on the bottom by an x. And again, I tried to write it up at the top so I would remember that it's in the numerator. When I distribute in the top, All right, when I take the x times 1, it's not a fraction to start with. I'm not going to have a fraction when I'm done. 1 times x is just x. Okay, then I'll have the plus sign. All right, 1 over x times the x. Now, this is a fraction. When I multiply through, I should get rid of the fraction. This x is on the bottom. This x is on the top. They're going to cross out. I'm just going to have a 1. Okay, distributing on the bottom. Okay, again, the 3 is not a fraction. It's not going to be a fraction when I multiply. 3 times x is just plain 3x. All right, here, 1 over x. This x is in the bottom. This x is in the top. Those x's are going to cross out because I'm multiplying rational expressions, and I'm just going to have a minus 1. Can I factor anything in the top or the bottom? Nope. Nothing else crosses out. I don't have matching binomials. So on this one, it's just that quick and you're done. Some of them have a lot of steps afterwards. Some of them have just a few steps afterwards. All right, but this is way better than trying to do keep it, switch it, flip it, or the way you did in Algebra 2. It's a shortcut. Multiply through by that least common denominator. You're going to get really, hopefully you're going to get really quick at it.